Okay, so I'm basically going to pick up where I left off. So 5p3 is 60. 6 math, 6p6 is 1. Sorry, is 6 factorial. So that's the same thing as doing 6 math factorial. Okay, so and other things that I just wanted to say that I didn't say. So just minimize that. So if you have 5c2, or 5c2 rather, 5c2, like I said, that's 5p2 over 2 factorial. So that's 5 times 4 over 2 times 1, which we said was 10. Okay, now 5c2 is the same thing as 5c3, because if you take 1, 2, 3, 4, 5 things, and you choose 2 of them, that's the same thing as disregarding 3. So 5c3 is equal to 5c2. If you have 10c3, that's the same thing as 10c7. Another way to write a combination is 10 with big parentheses and 7. That means the same thing as 10c7. Okay, so just to recap, permutations, order matters, keywords, arrangements, lineups, number of ways. Combinations is not important. That's keywords are groups, teams, committees, arrangements. No, not arrangements. Groups, teams, committees, and combinations. So remember, if you're picking groups in a combination, D and E is the same as E and D. These are the same. But in a permutation, D and E is different from E and D. Okay, so we're going to move on to the binomial, and I'm going to start this so that when you guys are done with your quiz, you can start looking at these types of questions. So let's take a spinner that has 3 sections. Okay, and I want to find the probability of getting 2 evens in 3 spins. Okay, so first we have to establish the probability of even. So the probability of even is 1 out of 3, and the probability of odd is 2 out of 3. So 2 evens and 3 spins. So you could have even, even, and then odd. Or you could have even, odd, even, right? Or you could have odd, even, even. Okay? So those are the 3 cases. And remember, whenever you have cases, it's plus sign. And to calculate these individual spins, one spin should be independent from each other. So we're going to actually calculate this through multiplication. So that would be 2/3. So we see here that that would just be 2 over, whoops, not 8, 27. And here, this would actually come out to the same 1/3 times 2/3 times 1/3. Again, it's going to be 2 out of 27. And here, 2/3 times 1/3 times 1/3 is 2 out of 27. So we add these up, 2, 4, 6. So the answer would be 6 out of 27. Okay, so now what I did was, I didn't use the binomial probability, but I'm going to show you now how to do this same question doing what's known as the binomial probability. So the binomial probability, the formula for it, and I'm going to try to keep it on this, is, the formula is NCR times P to the R and Q to the N minus R. So this is known as the binomial probability. Okay, so how do we know when to use the binomial probability? Well, it's always going to be a fixed number of trials. So you see here is 3 spins. That means it's a fixed number of trials. And what we have here is success. So success is actually getting an even. So this is success. Okay, so N is always the trials. P is always probability of success. And then Q is the complement of P. 1 minus P is Q, and that would be failure. Now the R here is how many successes you want. So you see you wanted 2 evens, so 2 is the number of successes. R is the number of successes, and here R is 2. Okay, so actually let me put here number of successes. Okay, so what I'm going to do right now is actually do the same exact question using the binomial probability. So the question said, find the probability of getting 2 evens in 3 spins. So 3 spins. Why 3? Because that's a fixed number of trials. So 3C2. Why 2? Because that's how many successes I want. Now, the probability of getting an even is 1/3. And now I want 2 of them, so 2 evens. So this number and this number, they should always match. Okay? Now, the probability of failure is always the complement of success, so this would be 2/3. So if you have 3 trials and 2 evens, naturally you would have 1 odd, and these 2 numbers always have to add to the number of trials. Okay, so now if we calculate this with what we learned, this is 3p2 over 2 factorial, right? So that's 3 times 2 over 2 times 1. See, that's just 3. And then here, that's 1/9. And here, that's 2 over 9. Whoopsies! Miss Morgan made a big mistake. Wait, no I didn't. 9 times 3 is 27. Oh, this is a 3. Sorry, that's 3. So here we have the 2 over the 27 times the 3, which gives me the 6 over 27. Okay, so now, you see that the question that I just did, the way I did it in purple is how we first did probability. Now, this type of probability fits under the binomial probability because there's a fixed number of trials. So do you see what this 3 does in front and in the formula right here? Right here in the formula? This accounts for the number of cases. So you see we had the 3 cases. That's the 3 cases. And each of these had the same probability in here. Okay? So that's the binomial probability. Now, just one thing I wanted to say as a side note, when you do combinations, you can never have like 3C5. So the bigger number always has to come in front, because if you're making groups, you can't make groups of 5 out of 3 things. Okay? So, all right, so let me just try. I'm going to try this sheet you're going to use. You're going to practice these questions after your quiz and for homework. So I'm just going to do like one or two of them. All right, so it says the probability that Team A will beat Team B in a sporting event is 2/3. Okay, what is the probability that Team B will win all 3 games of a 3-game series? Okay, so all 3 games. So you have 3 games. That's your fixed number of trials. Okay, now the probability that Team B will win, Team A will beat Team B in a sporting event is 2/3. So the probability that Team B will win is 1/3. So that's success. And you want Team B to win all 3 games. So again, this number always has to match this number. And then the complement would be 2/3 or failure. And then these two always have to add to the number of trials. So this is 3C3, which is 1, always. 1 over 3 cubed is 27 times, this would just be 1. So that's going to give me 1 out of 27. So that's the first one. Let me do number 3 with you. The probability of winning a game is 1/3. The probability of losing a game is 2/3. If the game is played 3 times, what is the probability of winning exactly twice? Okay, so 3 is the number of trials, and you want 2 wins. The probability of winning is 1/3, and the probability of losing is 2/3. Okay, so 2 wins, 1 loss out of 3 trials. So 3C2 is the same as 3C1, and 3C1 is 3. See how I did that? And 1 over 9 times 2/3, well, that's going to give me 6 out of 27. Okay, and I'm going to do one more with you, and then you guys can finish this. Let's do number 5. The probability that a professional baseball player will get a hit is 1/3. Okay, so calculate the probability he will get at least 3 hits and 5 attempts. Okay, so at least 3 is 3 or more, so that's 5C3 plus 5C4 plus 5C5. Okay? Now, getting a hit is 1/3. So 3 hits would be 1/3 cubed, and then no hits would be 2/3, and then again these two numbers have to add to 5. Here we get 1/3, that would be 4 hits, 2/3 to the first, and then here would be all 5 hits, and then 2/3 to the 0. Okay, and then you guys can do this out, but you get the hang of it. So just you can put these in your calculator individually. I'm going to show you tomorrow how to actually do this in your calculator. We're going to talk more about the binomial distribution. Okay. Hopefully the quiz went well. Bye.